Today I wanted to talk a little bit about hardware. We have been talking about software both in the Linux world and sometimes in the Windows world, but what does hardware have to do with software? That's sort of the topic here. And we are lucky to have James Jech, who is the senior manager from Dell, who's seen these hardware evolutions happen in his working life. And I wanted to just have a conversation with him about what that entailed, how it's going, what's new, what isn't new, what's come back, those kinds of things. Hope you enjoyed this. Welcome, James.
Thanks, a pleasure. And over the past 5 years, we've really seen a revolutionary, and I like to consider it evolution of the data center. In the past, we really had to rely on large monolithic systems, mainframes, minis, platforms that are very expensive, first of all, to not only procure, but even support over time. Typically, to get premium support on a large frame system, you're paying about 20% of the initial purchase price on an annual basis to continue to maintain that system. And today, what we've discovered is through the beauty of standardizing and building clustered architectures, we can use very inexpensive 2-4-way server platforms and deliver, in most cases, more than the performance of these monolithic platforms in days of old. So we have, IT now has more tools and options, both architecturally and from a performance and platform perspective than they did in the past.
Great.
So it's really empowered IT to select which architectures, one, best for them, then two, to also empower them to select either very costly or very inexpensive architectures that deliver even more performance than what they had in the past. So a good example of that is I manage the Oracle business unit at Dell.
Okay.
And what we've noticed is that even within our own IT group, Dell IT, and Dell IT is a Fortune 30 company in its own right as far as an IT organization. So they're very, very large. They probably one of my toughest customers on the planet because they literally can use anything under the sun, and pun intended. In fact, if you look back 5 years ago, half of our systems were running Oracle database on Sun.
Okay.
Yeah, on Solaris. And so back then, that was the only option they had. They were looking for high availability, they were looking for performance, and they were looking for a stable platform that would deliver the business operations for Dell, everything from manufacturing, supply chain management, shipping and receiving, order entry, our website, you name it. The heart and soul of Dell was running on.
So these are sort of mission-critical applications that couldn't be down, otherwise Dell stopped working. Right?
Exactly. And so we began a mission about 5 years ago to try to figure out how do we eat our own dog food.
Okay.
Because certainly we weren't getting a great price, nor...
And I'd like to explain what eating dog food means here, at least Microsoft, and I'm sure it means the same thing at Dell, which is, whatever you make, eat it yourself. Is that
Absolutely.
Okay.
Yeah. So it's the intent is to ultimately utilize your own products, especially the products that you're delivering to your customer base as well. So working in conjunction with Oracle, we developed these clustered architectures, which could utilize our 2 and 4 processor platforms. And today, that's called Oracle 10G Rack, Real Application Clusters. Back then it was Oracle's 9i Real Application Clusters. So we started rolling those out, and over about a period of 3.5 years, we actually migrated all of our Unix platforms to Oracle on Linux, and it's been a very successful migration for us. And in fact, so successful that our most mission-critical application is our supply chain management system. And as you can,
So this is the one. If you order a Dell computer, it gets sort of configured, built, and then all the inventory management happens, all the shipping, all of that is done by the Dell supply chain system.
Absolutely, and in fact, all the supplies, once you click order, the supplies for us show up at the factory within a 4-hour window that's predictable.
Oh,
And that's how we control costs and the supply chain.
Okay.
So, as you can imagine, the supply chain aspect of our business is critical to the point of about 60 or 56 billion or 57 billion per year.
Wow.
And if that system goes down for a single hour, our global supply chain literally ceases to work.
Wow.
So we stopped the $57 billion machine. So last year, we actually took on the monumental task of migrating those original mainframe systems to these Dell servers. And to our surprise, and really, we're quite happy about it.
Yep,
We went
sure.
from $1 million frames down to, I think the primary site has 6 4-way servers that cost about $30,000 a piece.
That's a huge saving there.
We basically procured the new platforms with 3 years of premium support for the cost of 1 year of maintenance on a mainframe system.
Wow.
And the thing we like about these systems is that architecturally they're clustered, first of all, which allows us to have extremely high availability. No longer are we relying on 1 or 2 large mainframes because they cost so much. You can't buy lots of nodes. We have 6 nodes in the cluster, and we can grow it to as large as we want. The actual architecture also lends itself to be refreshed down the line. So from a hardware perspective, part of my problem is hardware changes every year, and it ages, and eventually an insidious thing occurs called MTBF, mean time between failure. And so it's just a calculation of the electronic components, how many you have, and the likelihood of them, any single component failing. And it's no surprise that most manufacturers recommend that you replace your hardware, refresh it every 3 years. And the longer you wait, the more likely it is that you either have a failure in your system backplane, which is catastrophic, or maybe something small like a floppy drive, and nobody cares about that. But at some point, something will fail. And that's where clustering and high availability becomes very important for a mission-critical assignment like driving the supply chain at Dell.
So, I mean, there's, some people would say that mainframes are kind of easier to manage. Do you actually see that, or is the software, with operating systems and the management monitoring software, make it almost the same? What do you see there?
Yeah, we've actually seen the convergence or the gap being closed between singular monolithic mainframe type systems and how they're managed. And the argument there is I have one system to manage. But the reality is that system is usually partitioned into multiple areas, which is the same thing as having a cluster with multiple servers managed as one system virtually. So the software itself, Oracle Enterprise Manager, for example, gives you pictorially a schema and view of the entire clustered database as a single entity. Now, we've taken it one step further. Besides managing the database and the nodes, we also have Dell Systems Management hardware code built into 10G Release 2. So you can actually drill down into the hardware and get the monitoring statistics and alerts. If a hard drive fails or if a fan goes out, it'll actually alert you from the DBA's comfort zone, which is their Oracle Enterprise Management tool. So we've made it seamless as much as possible anyways, so that the admins are looking at tools that they're used to using. They don't have to go and launch or initiate a hardware tool to manage their production system. It's all done from one console. And that's how we address the manageability of these hardware platforms and the integration of the software and the operating system and all those things.
So you've been around the hardware industry for a while. People keep talking about commoditization of hardware. Is it really commoditization, or is every little piece of hardware now has value add? What are your thoughts about that?
I think that it's commoditization via the standardization of common building blocks. There's always what is the end-all goal of this process? What do we want to achieve by standardizing these components? And the fundamental basis of the standardization is to, if you can imagine, at some point in time, and we're partway there, we've got grids, large structures of very small, inexpensive servers that we can repurpose and reuse in any manner we wish to.
Right.
Part of the challenge we have today with monolithic architectures is that if you take finance, great example, at their peak usage, which is at the end of month, end of quarter, or end of year, you need, for example, 28 processors.
Right.
And then after that period of time, for the next 28 days, your CPU utilization drops down to about 4%. So you've wasted all that energy to power it, to manage it. The software to run it is very costly, and your utilization peaks and valleys for the majority of the time.
So you're basically paying for peak usage instead of average usage.
Exactly.
Okay.
So what we want to do with these grid-type architectures is really to balance that out. So instead of having one very large platform that you only use periodically, we have many, many platforms that provide that same power and memory capability, and we repurpose it as needed. So in the morning, I may need more portal servers to log in all the employees. In the afternoon, I may need to repurpose those for other tasks such as backup, disaster recovery, or some scripted process to run a report for finance.
Right.
And so I would repurpose systems from database to application and so forth.
So are you seeing that the operating systems, whether they're open source operating systems like Linux or Windows, are they actually catching up to that kind of potential? Are you seeing that? Or?
They are, and it's it starts usually performance and availability are the first points of required effort,
Right.
I should say. And then afterwards, once we figured that out, then the industry tends to focus on manageability as almost an afterthought, although it should come much sooner. So what we're seeing today is, if you take Windows, for example, for quite some time, Windows had an innate memory ceiling of 4 gigabytes.
Right.
And now, with the advent of 64-bit Windows, we've discovered that, and our customers especially have discovered, that instead of a performance limitation of about 150 concurrent users on a single node, we've seen a jump with 64-bit upwards of 1,300 concurrent users.
Okay.
So magnitudes of capacity now. And by the way, I only stopped at 1,300 because we didn't think it'd go that high.
Right.
And we didn't think far enough to add enough load generators, servers in front of it. We're not quite sure where it would have ended.
Okay.
But what that means for our customer base today, they really had two options in the past, just like Dell IT. They had Unix or Windows, and then Linux came along, of course. And for a lot of them, the Unix guys thought, oh, Linux would be a perfect bridge for me.
Okay.
Now, that's not always the case with accounts such as the government, who have a dual OS approved vendor list.
Right.
They can only support 2. Or if you're a small business and you can only support 2 operating systems, you don't want to add that third one.
Right.
So today customers have really 3 choices. Unix, the most expensive choice. Linux, which is sort of the new Unix, if you will, and that helps you with the commoditization and standardization of your infrastructure. But then Windows now, which I think is quite an interesting and good option, because most all IT shops today have Windows 10. It's inherent. They use it for their web services, their applications. It's a common platform. And the missing ingredient was really the performance. It has that today. And it has Microsoft, of course, backing it from a business perspective, both via support and all the other benefits that come along with a well-developed operating system. So we're there where we have the convergence of business, performance, and technology that makes the Windows 64-bit OS a very viable platform and successfully being deployed throughout a very large portion of the Oracle business today. Our Oracle business is growing about 80% year over year, and the growth that we see in that is really attributed towards Unix migration.
Oh, okay.
Customers, if you asked me 3 years ago, I would have said, yeah, we're just starting that. Today, Unix migration is a common play. More than 2/3 of all our Oracle-oriented business is of that vein.
So I'd like to drill down into this a lot more. Hopefully we can have more conversations with you and drill down into what 64-bit means, how that works in the open source world, how that works in the Windows world. Thank you very much for your insight. Folks, I always wanted to say this. This is Anandeep Panu, Senior Program Manager at the Open Source Software Lab, signing off. Goodbye.